Greetings and welcome back to section 16. It's the law per Mr. Ohms. So we're going to go over Ohm's law. Okay, it's the law per Mr. Ohms. Okay, the term that describes the rate of which electrical energy is used is called power. The basic unit of electrical power is measured in watts. The formula used to calculate power in a DC circuit is power equals voltage multiplied by current. And I'm going to get this into the next slide. There's something called the magic circle, which I'm going to show you in a minute. You can write this down, pi, P over I times E. This is called the magic circle. So there's two magic circles in this test. And you can write this down as soon as you get your scrap paper. P over E times I. So I'll show you how to use this next. The power being used in a circuit when applied voltage is 13.8 volts DC and the current is 10 amps. So solving for P, we cover up the P and we multiply E times I. So we cover over what we want to look for. We're looking for power. And 13.8 times 10 is 138. So E is given as 13.8 volts, I is given as 10 amps. P equals I times E. P is equal to 10 times 13.8, which is 138 watts. So in your test, I would bring your calculator. It can't be a programmable calculator. I would suggest like a TI-30. They're pretty good. Or you can go down to the dollar store and get a regular old dollar store calculator, and that'll work just fine for this test. There's no heavy math in this. It's all in units. So you don't have to worry about scientific notation or powers of 10 and stuff like that. So this is all going to be in units, and if you can multiply, you can divide, you can add, subtract, you can pass this test without a problem. Okay, the power being used in a circuit when the applied voltage is 12 volts and the current is 2.5 amps. So we want to solve for P, so we cover up the P, and it's E times I. E is given as 12 volts, I is given as 2.5 amps. P equal to I times E. P is equal to 2.5 amps times 12 volts, which gives us 30 watts. The amount of current flowing in the circuit when the power in the circuit is 120 watts and the applied voltage is, okay, so we want to solve for I, so we go ahead and cover up I, so it's P divided by E. So P is given as 120 watts, E is given as 12 volts, so I is equal to P over E, which is 120 divided by 12, which gives us 10 amps. This formula is used to calculate voltage in a circuit. Voltage equals current multiplied by resistance. So here's your magic circle, E over I times R. So this is the second magic circle you can write down, EIR. And it works the same way as the power one. If we just cover up what we want to solve for. Let's begin. The voltage across the 2 ohm resistor if the current of 0.5 amp flows through it is. So we're looking for voltage. So we cover up the E, which is for EMF, right? E is EMF for voltage. So it's I times R. So E is equal to I times R. E is equal to 0.5 amps times 2 ohms, which gives us 1 volt. The voltage across the 10 ohm resistor if the current is 1 amp. So we want to solve for E. Again, I times R. So E is equal to I times R. E is equal to 1 amp times 10 ohms, which gives us 10 volts. The voltage across the 10 ohm resistor if the current is 2 amps. So we're looking for voltage. So we cover up the E, and it's I times R. E equals to I times R. E is equal to 2 amps times 10 ohms, which gives us 20 volts. The formula used to calculate current equals voltage divided by resistance. So we want to find out current. It's E over R. Okay, current flowing through a 24 ohm resistor connected to 240 volts. So I is equal to E over R. I is equal to 240 volts divided by 24 ohms, which gives us 10 amps. Current flowing through a 100 ohm resistor connected across 200 volts. So again, we want to find current. I is equal to E over R. I is equal to 200 volts divided by 100, which is 2 amps. The current flowing through an 80 ohm resistor is connected to across 120 volts is. So we want to find I again, E over R. I is equal to 120 volts divided by 80 ohms, and that gives us 1.5 amps. This is the formula used to calculate resistance. R is equal to voltage divided by current. So now we want to solve for R, so we cover up the R in the magic circle. So the resistance of the circuit, we got 3 amps, 90 volts. So we look at a magic circle, it's R is equal to E over I. R is equal to 90 volts divided by 3 amps. R is 30 ohms. Okay, the resistance of the circuit, which is the applied voltage 12 volts, and the current flow is 1.5 amps. So again, we want to find R is E over I. R equals 12 volts divided by 1.5 amps, which gives us 8 ohms. The resistance of a circuit that draws 4 amps from 12 volt source is, so again we want to find out R is E over I. R is equal to 12 volts divided by 4 amps, which gives us 3 ohms. And this is the full magic circle for Ohm's law. And this one, if we want to solve for, let's say, P is equal to I times E. P is also equal to I squared times R. P is equal to E squared over R. If we want to find I is equal to E over R. I is equal to P over E. I is equal to P, the square root of P over R. We have R is equal to E over I. R is equal to E squared over P. R is equal to P over I squared. E is equal to the square root of P times R. E is equal to P over I. E is equal to I times R. So that is the full magic circle. You don't have to memorize this. I would measure the PIE one, the pi, and the EIR one. That's the only two you need to know for this test. The outer edge is resistor color codes. So black is 0, brown is 1, red is 2, orange is 3, yellow is 4, green is 5, blue is 6, violet 7, gray is 8, white is 9, and the 2 tolerance. You have also a compass rose here, and this is the hands of a clock. 1 o'clock, 2 o'clock, 3 o'clock, all the way up to 12 o'clock. We have military time. 13 is 1 o'clock, 14, 2 o'clock, 15, 3 o'clock. So this outer ring is time. So it's a pretty useful little doodad. Alright, so next on to the Q&A section of It's the Law per Mr. Ohms.